This question is given in GATE 2008. Now see this question. Consider the following assertions. Statement 1. For the Zener effect to occur, a very abrupt junction is required. Statement 2. For a quantum tunneling to occur, a very narrow energy barrier is required. Now, which of the following is correct? They have given two assertions, that is two statements. We need to tell which of the following is correct. Only statement S2 is true. S1 and S2 both are true, but S2 is not the reason for S1. And option C, S1 and S2 both are true, but S2 is not reason for S1. And option D, both S1 and S2 are false. Now in this kind of questions, you need to see each and every statement. Sometimes third statement S3 will also come. Okay, so you have to deal with each and every statement such that you have to be clear. Then only you can put whatever the correct option. Otherwise you may end up with the wrong answers. Okay, now coming to the statement 1. For the Zener effect to occur, a very abrupt junction is required. Now coming to the PN junction, it will be basically two types. Okay, one is step graded, another one is linear graded one. Now this step graded is also known as abrupt. Okay, abrupt junction. Now the meaning abrupt came from the following diagram. You see this. This is the depletion region. Let us think. This is the depletion region. Now the carrier concentration, how it will be, I will show with the diagram. Okay, this will be plus, this will be minus, this will be at this point it will be 0. Now 0 plus will be highest point of concentration, that is large concentration. This point will be very less concentration. Now it will have at 0, we cannot say that charge carrier concentration is 0 or positive or negative. We can't say. Okay, from here to here it is going abruptly. So it is going abruptly such that we cannot say about exactly the charge carrier concentration. Whereas in linear graded, you see here, it will be like this. This will be 0 and it goes on linearly increasing and it will be positive. So this type will be fully positive. Here it will be negative. So this is of linear graded. And coming to the exactly point, Zener effect Zener effect can occur either in step graded or linear graded. It can occur in both. Okay, but in the statement if you observe, it is saying that Zener effect to occur, very abrupt junction is required, which is false. The statement is false because Zener effect can occur either in this or this, both. Okay, that is why statement S1 is false. Coming to the S2, for the quantum tunneling effect to occur, a very narrow energy barrier is required. Now obviously Zener effect can occur either in step graded or linear graded, but only main point is it should be heavily doped from both the sides, P side and N side. It should be heavily doped. Now there are two kinds of effects, it can occur in surmounting process or it can occur in tunneling effect. Now I will define what you mean by tunneling effect and what you mean by surmounting process. Now surmounting process. This surmounting process is nothing but, you see this, when it is in forward bias, this is P side, this is in N side. Now here the energy gap is very high in the surmounting process. Whenever it is moving from P side to N side, so N side to P side, it has to come from lower energy level to higher energy level. If you see here, it has to cross certain level of energy. Okay, now coming to the point, now instead of entering into barrier, it can directly jump from this side to this side. Okay, instead of entering in this way, it is jumping. It is called surmounting process. Now coming to the tunneling effect. Tunneling effect, this is very important. Tunneling effect is very important. Here very thin energy band gap is there. Okay, even though it is heavily doped, thin band gap is there. From p side to n side, electron moves from n side to p side. Okay, instead of surmounting or instead of jumping, it straightly penetrates from n side to p side. It has to penetrate from, it is penetrating from n side to p side instead of surmounting it. Okay, so it is moving from, otherwise you can say that, filled energy level to empty energy level. This should be the main condition. It is moving from the filled energy level to the empty energy level. Instead of jumping over it, it is breaking the potential barrier, or it is coming, like it is penetrating through the potential barrier. This is the right term to use, penetrating through potential barrier. Through potential barrier. The full concept of this tunneling effect we will see in the concepts, we will see in the subject. Okay, now up to this, in the exam point of view, you just have to remember this. Okay, now for the tunneling effect to occur, it has to break this energy barrier, and it is narrow one. You see, compared to surmounting, it is very narrow. So you can say that for quantum tunneling to occur, a very narrow energy band gap barrier is required. This is true. Now coming to the options, only S2 is true will be the correct answer. Only S2 is true. Okay, in this way you can solve this kind of questions.